Hi everybody, and welcome to Headland Machinery's Waterjet webinar series. This is week 4, and this week we're going to be looking at the different types of UHP pumps available that you can get with your Waterjets, and take you through the advantages and disadvantages of each type, and hopefully going through and answering any questions you may have. All right, let's get stuck into it. So first of all, we're going to go through what different types of pump are available, and also we'll go through what type of UHP pump is going to work best with your application, because they all have their place. They all work best in some applications than others. So we'll go through that, and hopefully that'll give you some idea of what's going to be best for you. So the original type of ultra high pressure Waterjet pump is the hydraulic intensifier. A couple of pictures you can see on the screen here of the hydraulic intensifier. These are some of the more modern ones with electrical switching as opposed to mechanical switching and things like that. The hydraulic intensifier basically uses hydraulic oil to move the piston backwards and forwards, which then pushes the Waterjet pistons backwards and forwards to generate the ultra high pressure water. To move on to the next slide in the deck, you'll see a bit more of an explanation of that. So on this one here is your hydraulic cylinder. The oil comes down in, pushes the cylinder that way, which pushes your ceramic plunger this way. Water then goes out of here and pressurized behind the orifice. And then once it reaches this end, it hits this firing pin, which shifts the pilot valve, which then puts oil back on this side and pushes it back that way. So it just moves backwards or forwards as it's stroking, pushing the water out either end in turn. As you can see by this picture on the side, it's quite a complex system. It's not a simple solution by any means. There's quite a lot of hydraulics involved. Plus also you need an attenuator as well. What an attenuator is, it's a big storage facility for ultra high pressure water. And that basically smooths out the pressure spikes you get when the cylinder switches. So as you can imagine, once the cylinder reaches the end of its stroke, it then has to switch and go back the other way. So when it switches to go back the other way, there's a momentary loss of output. So there's a drop in pressure. As it goes back the other way and picks back up, there's a big spike in pressure. So you end up with quite a lot of spiking in your pressure delivery. So they have to use attenuators to try and smooth that spike out. As you can see, that adds another level of complication to the circuit. So as you'll see on this drawing here, there's quite a few bits and pieces to it, from the pilot valves to the intensifier itself, booster pumps and controls, and the hydraulics pump and the hydraulic motor and the reservoir tank and all the bits and pieces that come with that. It's quite complex things. The second type, staying with the hydraulic intensifier, my apologies, look at the pros and cons. So what's the pros for hydraulic intensifier? Well, it's proven technology. That's one. It's been around for probably about 40, nearly 50 years now. Hydraulic intensifiers, they're well proven in the market. What they're fantastic for is running multiple nozzles at once. So if you have, let's say, for example, a couple of manufacturing cells set up using a robot-mounted Waterjet, and you want to use that to cut anything from car floor plans to nappies to vegetables, all kinds of different applications for that those production cells. And you've got multiple independent switching nozzles, then a hydraulic intensifier is the perfect pump for that application, because it can self-compensate for the varying flow rates which come when you switch multiple nozzles on and off. So it's really, really good for being able to compensate for that and making sure that the pressure is maintained and the flow rate is maintained. Another really good thing about hydraulic intensifiers is you can generate really, really high pressures with them, in some cases up to 87,000 PSI. That comes with its own drawbacks as well, but you can generate really high pressures. So the downsides of hydraulic intensifiers is they're quite complicated to maintain. You need to understand hydraulic circuits and not just UHP circuits. As you say, it's hydraulically driven, so it can be quite inefficient, because a lot of the energy that you're putting into that system, into the electric motor, gets lost and transferred into heat within the hydraulic system. So that heat moves in, loses the energy. Therefore, you're only getting approximately about 60% efficiency out of your hydraulic intensifier. They can be expensive to run and maintain. Because of the way the hydraulics work, they're quite noisy to operate, very loud, and also involving all the hydraulic oil, you're generally going to get some leaks and some spillage and bits and pieces. So they're quite dirty to operate. They're not a very clean system. And because of the heat that's going into the hydraulic system, you've got to have a chiller. You have to have a chiller to cool the hydraulic circuit down, to keep that in working condition so it doesn't blow seals and so on and so forth. Second type of ultra-high water pressure pump is the servo-driven reciprocating pump. So this, on the surface, is very similar to a hydraulic intensifier, but instead of using hydraulics to stroke the piston back and forwards, it uses a servo motor on a lead screw. So that lead screw basically moves backwards and forwards, which moves your plungers in and out, which generate your ultra-high pressure water. So as you can see, there's your servo motor there, instead of the hydraulic piston. So it's a very, very similar concept to a hydraulic intensifier, but because it doesn't intensify anything, it can't be referred to as an intensifier. So it's just a reciprocating pump. Now, what are the pros and cons of that? One of the biggest positive features of the servo-driven pump is it's very, very quiet indeed. And it just sits there and purrs away in the corner. It sounds like a dishwasher, just sloshing a bit of water about. The way that they've been designed, they're quite fast just to change over a single seal. That's normally not what you do with a full maintenance though. Normally if you're doing maintenance, you need to replace more than just the seal. There's check valve components and cylinders and all this kind of stuff as well. So it is fast just to change it one seal, but that's not normally what you're going to be doing. So as I just described, that can lead to quite complicated maintenance. The spare parts are quite expensive for these types of systems. Again, they're inefficient, and how that shows itself is in the lack of hydraulic horsepower. Now, in previous webinars, I've spoken about hydraulic horsepower at the nozzle and what that means. So basically, the higher your hydraulic horsepower at the nozzle, the faster you can cut. The lower, the slower you cut. And it's not down to pressure. It's not down to anything else other than hydraulic horsepower at the nozzle. Now, the more efficient your pump and the more powerful your pump, the higher your hydraulic horsepower is going to be. Now, with these servo-driven pumps, they will generally use a 50 horsepower motor. And with that 50 horsepower motor, you can only use an 11 thou orifice, which is roughly about 1.7 litres a minute of water at 55 to 60,000 psi. To give you an idea of how that compares to the other styles, your hydraulic intensifier using a 50 horsepower pump will be able to use a 14 thou, which is roughly about 3.5 litres of water a minute at, say, 60,000 psi. Whereas your direct drive pump, which we'll get onto in a minute, that 50 horsepower pump can use a 16 thou nozzle, which moves approximately about 6 litres of water a minute. So as you can see, and that's at 60,000 psi. So as you can see, that's a much, much higher flow rate of water, therefore much higher hydraulic horsepower at the nozzle. So same power input, 50 horsepower motor. The difference is 1.7 litres a minute with a servo-driven pump to 6 litres a minute with a direct drive pump, and 3.5 to 4 litres a minute with a hydraulic intensifier. So although they may be quiet, they're not very powerful. And that also then results in slower cutting. And again, with these types of pumps, they have issues with the electronic system on them, which requires cooling. So again, you have to have a chiller. Now, the third type is the direct drive. Now, this is the type that Omax supply. They don't supply anything else other than direct drive pumps. To give you a brief bit of history, bit of background, when Omaxes were first released back in the mid-90s, they used to run hydraulic intensifiers. The guy who started Omax was a gentleman called Dr. John Olson. Dr. John Olson was the inventor of the hydraulic intensifier. If you look online, there's many forums talking about that, and how John Olson was like the father of abrasive waterjet cutting as we know it. And he invented the hydraulic intensifier. And in his company, with his tables, he decided but the way forward was with direct drive pumps. So this is the guy who's invented the hydraulic intensifier. He's saying, no, on my systems, I want direct drive. That in itself has got to tell you something about the direct drive system. So Omax only supply direct drives. As you can see, they're a lot simpler. It is literally just an VFD supplying an electric motor that turns the crankcase and that pumps the water. Very simple circuit. So if you compare that to this system here, as you can see, it's incredibly simple. Pros and cons. So pros of a direct drive pump, because of the highest hydraulic horsepower, you get the fastest cutting speeds. And that, again, those efficiencies make it the most efficient pump available, in some cases upwards of 90% efficiency. That then equates to a low running cost. That also gives you the best application for cutting with a single nozzle. So as I explained before, if you're running multiple nozzles, switching at multiple times, at complete different times, then a hydraulic intensifier is best. If you're running one nozzle, like on an XY cutting table, for example, then a direct drive pump is best. On the direct drive systems, you do not need a chiller as long as your ambient water temperature is below 23 degrees. You do not need a chiller. And it runs a variable frequency drive. Now, what's the importance of the variable frequency drive? American electricity is running on 60 hertz. Australian electricity is running on 50 hertz. Now, what that means is if you've got a 50 horsepower motor, that is actually only going to be running at 40 horsepower because of the difference in the hertz of the electricity supply between America and Australia. What the VFD does is it takes that incoming 50 hertz power and converts it to 60 hertz, so the motor is actually running at its full capacity. And that is another reason why the direct drive's efficiency levels are so high. As I said, one of the only real drawback with the direct drive is that you can't run multiple nozzles switching at independent times. Other than that, it's probably one of the best pumps you can get your hands on. It's fast maintenance as well, long maintenance cycle, so you have a long time between down periods, downtime for doing maintenance, and it's not down for very long because they're fast to maintain. Okay, so if you have any questions following that presentation regarding what pump is best for you, please feel free to send it to me either on an email at mattheww@headland.com.au, or alternatively, you can give me a call on 0427 462 678, and I'll be happy to go through anything with you in more detail. Okay, well, thank you very much, everyone, and I look forward to seeing you all next week. Thanks.